And away we go. We are going to engage in the development of the idea of place value, and I need to do it in a way so that you feel what it would be like to be a young learner who doesn't know all this stuff already, to think through what place value really means. And so the way we're going to do it is I'm going to introduce to something that I just made up. I call it the sonic number system. And just to be honest, I made it up when I was working on this years ago, and I had a Sonic drink in front of me. And so when I went to name my number system, I just called it the Sonic number system. But here's how it goes. You know how I was saying in the previous video that the symbols that we write to represent quantities, to represent numbers, are just symbols to represent numbers. They're not the number itself. So as you think through this, I want you to think about how the quantity under consideration in our brains is being represented by a symbol. And we're going to start over here. In my number system, there are only five. I'm going to get rid of this background. There are only 5 different symbols that we can use. There's a symbol for 0, 1, 2, 3, and 4. That's all I have at my disposal. And you might think, well, that's crazy, but it really isn't. In our current number system, we have symbols for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all we have. And then we use those symbols to represent all of the other numbers. So likewise, in this number system, there are only 5 symbols instead of 0 through 9, like in the traditional number system. There's 0 through 4. So 0, 1, 2, 3, and 4 are the 5 numbers that we're going to, or the 5 symbols that we're going to get to use. And here's how it works. Suppose you had 4 objects. I'm using these little blue dots as just representation of a quantity. So suppose I had 4 blue dots. If I wanted to communicate to the world that I had 4 blue dots, I would use this symbol right here. Now, I know you're used to our traditional number system, the number 4, but I'm inventing a new number system, and that number system is a square is going to be used anytime we want to communicate that we have 4 items. And then if we had 3 objects, 3 blue dots in this case, we're going to use the triangle symbol to represent the idea that we have the quantity of 3. I hope you can see where I was going with this. The square has 4 sides, so that will help us remember that a square represents the idea of 4. A triangle has 3 sides, so it represents the idea of 3. And what happens when we get down to 2? When we get down to 2, if you want to communicate to somebody that you had 2 somethings, in this case 2 blue dots, we're going to use this little symbol, this chunk chunk symbol. It has 2 edges to it. There's that top edge and a side edge. And then if you wanted to represent the idea of just 1, you have 1 something, 1 blue dot, we're going to use the upside down A. Now, upside down A because A is the first letter of the alphabet, but I wanted to flip it upside down because I want us to feel what it's like to be a kid who doesn't know the number system symbols so well when you're 5 years old. You are engaging in that number system that we know so well, kind of like you are going to be engaging in this sonic number system because it's kind of weird. You just have these weird symbols that represent numerical quantities, and you're going to have to get used to writing them. And then finally, if you had nothing, if you wanted to communicate to the world that we have 0 of something, we have no blue dots, you're going to use the circle with the X through it to represent the idea of nothing. Nothing in our, no quantity to think about. All right, so with that in mind, and I'll keep bouncing back to this slide, and you'll see it in other things as you work through this module, but those are the 5 numbers that we can work with. So suppose you wanted to, you were working on something and you had to represent the idea of 3. And in the idea of 3, find my thing. And the idea of 3, where you have 3, let's just use dots to represent these ideas. We'll use the blue dot idea. Well, let me get up blue. So, and we're going to keep track of it just to help ourselves keep track of how many we have. We're going to start over here on the right, and we're going to say, look, I have 1 blue dot. I have 2 blue dots. I have 3 blue dots. And if you did indeed have 3 blue dots, to represent that, because this is not the symbols that we have in the sonic number system. We're instead going to use this symbol to represent the idea of 3. So in the world, in the sonic number world, anytime anybody wrote down a triangle, everybody would understand, oh, you must have 3 of something. All right, cool. Now, what if you had 5 of something? What if you had 5 blue dots? How would you use the sonic number system to represent the idea of 5? Notice there's no symbol for 5. There's a symbol for 4, for 3, for 2, for 1, and for 0, but there's no symbol for 5. What would you do to preserve the idea of 5? That is a quantity that's possible, and we need a symbol to represent that. Now, here's the thing. You can't invent your own symbol. Let me explain what I mean. In our conventional number system, we have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not a special symbol for, say, 14. We use the symbols that we have, and we create 14. So likewise, when we get to this number 5, you're not allowed to invent a new symbol. You can only use the symbols that you see here. How would you, and why would you do that? How would you create the number 5 in the sonic number system? I was able to do it pretty easily with 3, because if you had 3 dots, we would just represent the idea of 3, quantity of 3 with the triangle. What are you going to do with a 5? Now, I need you to pause the video. Like really pause the video. Get out a piece of paper and a pencil, think, maybe draw what you see on the screen, put dots, and think about how would you go about doing this. All right, when you're ready, push play again and you can see how it plays out. But pause and try. Go. All right, I hope you've actually tried this, and I'm going to share with you, I've been doing this for years, and often what people do to express the idea of 5 is they say, well, the 5 would just be the 4 symbol followed by the 1 symbol. Now, if this is back in a classroom, I would be walking around the classroom and watching what people were doing, and they might write a 4 next to a 1, and they would say that's a 5. And I would say, oh, well, why is that a 5? And they'd say, well, because there's 4 here and 1 here, and together that makes 5. Oh, together that makes 5. So what they're really thinking is not a symbol for 5, is they're thinking 4 plus 1. And if that's the case, couldn't you say triangle symbol, so 3 and 2 also makes 5? Or couldn't you go the other way around? Couldn't you go 1 and 4? Or 2 and 3? So in other words, there would be lots of possible ways to make 5. And that would be kind of weird, is how do you know what people mean? I mean, in our real number system, there at base 10, when we have 10 symbols, I mean, there is the number 5, and there's no other way to make a 5. So likewise, I want to come up with a way that we can consider 5 using sonic numbers, such that there's no other way that we can make a 5, and everybody would understand 5. But furthermore, putting symbols next to each other does not mean that you add the symbols. For example, I'm going to share with you my age. Here's my age as of this video. Now, if I put a 5 next to a 6, and I told somebody, if I wrote down my age, would anybody look at that thing and go, oh, a 5 next to a 6, I would add those two together, and therefore that guy right there is 11. Nobody would think that. So putting 2 digits next to each other, putting 2 numerical symbols next to each other, doesn't mean that you should add the 2 numbers together to get the quantity. It means something else. What does it mean? And so I'm going to stop talking. I hope you push pause one more time. And if you've done any of these things or something like it, I'd like you to reconsider that putting symbols next to each other with an implied plus sign to say 4 plus 1 or 3 plus 2 or whatever is 5. That's not going to cut it, because there's then all kinds of ways you could express 5. And second of all, in our traditional number system, when we have our 10 symbols, 0 through 9, putting numbers next to each other does not imply addition. So if you have 56 years of age, you don't put a 5 next to a 6 and imply that it means 5 plus 6 is 11. That doesn't make sense. So push pause, try again. All right, I hope you gave it a shot. Now let's think through this together and see if this makes sense. So I've got 5 of these blue dots, let's say. I'm going to start putting those blue dots together into these little boxes here. You'll see why in a minute. But there's 1, there's 2, there's 3, and there's 4. Now I'm going to pause there for a minute because if I only had 1 dot, I would use the symbol for 1 in our sonic number system. If I had 2 blue dots, I would use the symbol for 2. If I had 3 blue dots, I'd use the symbol for 3. And if I had 4 blue dots, I'd use the symbol for 4. Life would be good. But when I get to 5, it gets a little awkward because I don't have a symbol for 5. And so here's what we're going to do. Once we get to 5, we're going to acknowledge that there's no symbol for 5. And what we're going to do is we're going to grab those 5 dots and we're going to bundle them together and move them over to this spot. Now in doing so, I'm thinking I've bundled them and moved them so they no longer exist. And so I've got one dot over here. Now one what? It was one bundle of 5. So when I move bundles of 5 dots over to the next rectangle here, what I'm keeping track of is how many groups of 5 do I have? Where over in the first box, I was just keeping track of single blue dots. If I had 1 dot, I would put a 1. 2 dots, 3 dots, 4 dots, I would just use the appropriate symbol for 1 through 4. But as soon as I got to 5 dots, let me put them back here just for a moment. Once I got to 5 dots, I bundle those 5 dots, and now in my brain, I'm going to keep track of how many bundles of 5 do I have. And so this 1 dot here isn't a literal 1, it's 1 bundle of 5. And so now look at what I have. Let me go back since I moved those dots. I'm going to erase them again. I moved them, I bundled them and put them over here. So now look at what I have. I have one bundle of 5 and no singles. And so in the sonic number system, the number 5 is going to be represented by 1 bundle of 5 followed by no singles. See, that's what place value. Think about those 2 words. Place, there's a place that these numbers exist in, and there's a value for that place. So place value. And in this case, that 1 dot was actually the 5 that got bundled together and moved over. So now its value is 5. How many bundles of 5 do I have? So I have 1 bundle of 5 and no singles. Okay, now just to make a connection, in our regular number system, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's all we have. What do we do when we get to 10? Well, you know, you put a 1 next to a 0. That means 10. But why does it mean 10? It means 10 because if you were doing dots, you would have had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. But as soon as you got to the 10th dot, you would have bundled those 10 dots and moved it over to the next place that has a value. And so even this 1 next to a 0 is 10 because it represents 1 bundle of 10 and 0 single dots. Just like this 1, 0 represents 1 bundle of 5 and no single dots. So there's number 5. Now, you can go back and pause and think about this some more, but you can also keep going. What I'd like to do next is the number 9. Using sonic numbers. Keep in mind, all you have at your disposal are these 5 symbols. A symbol for 0, 1, 2, 3, and 4. You don't have any other symbols to choose from, but you do now have the idea of place value. So pause the video. Start placing dots into this grid here. You can do it on a piece of paper. How many dots and what are you keeping track of and what are you bundling? See if you can express the number 9 using our sonic number system. Pause, give it a shot. I hope you gave it a shot, and I'm going to take you through it now. 9. Here's what 9 would look like. So first of all, keep in mind, we are first going to keep track of just singles, just ones. So if you had a single blue dot, you would use that symbol for 1, that upside down A. If you had 2 dots, you would use that kind of backward 7 looking thing. If you had 3 dots, you'd use a triangle. If you had 4 dots, you'd use a square. But if you had 5 dots, you would take those 5 dots because you've run out of symbols. You don't have a symbol for 5. So you would take those 5 blue dots and you would move them to a new place that has a new value. And you'd collect them or combine them all into a single dot. But those single dots are keeping track of how many bundles of 5 that you have. So I'm going to erase this because what I'm doing, if I was in the classroom with you and had some manipulatives, we would literally bundle together these 5 dots and move them over to the place value so they wouldn't even exist in this place anymore. They would all be over here in a bundle of 5. But that's only 5 dots. I still have some more dots. So I have 6 dots, I have 7 dots, I have 8 dots, and I have 9 dots. And now notice over here in the ones, it's fine. I didn't get to the 5th dot. I have a symbol for 1, for 2, for 3, and for 4. So I don't have any issues here, but here's what I now have. Notice I've got 1 set of 5, and I have 4 singles. And so the number 9 in the sonic number system is a 1 followed by a 4. And again, it's not a 1. It's not a literal 1. It's a 1 group of 5 or a bundle of 5. And then 4 singles together makes 9. And now, remember before with 56, I was saying nobody puts 5 and a 6 and adds them together to get 11. That's true. But it's also true that you do this. 5 next to a 6 means that I have 5 bundles of 10. 10, 20, 30, 40, 50. I have 5 bundles of 10 followed by 6 ones. So I have 50 plus 6. Oh, there actually is some addition happening in there, but not in the way you may have done it initially. It's 5 bundles of 10, 50 plus 6. It's 1 bundle of 9. 1 bundle of 5 plus 4 is 9. So in a sense, there is an addition here, but the addition happens when you consider both the place and the value. When I move over to this place, I'm keeping track of bundles of 5. So there's a place and a value. There's 1 bundle of 5 and 4 ones for a grand total of 9. All right, now see if you're getting it. Try 11. Pause, and then try number 11. All right, I hope you actually did pause, and I hope you're really going to try 11. But here's how I would think through it with 11 dots. First, I'm going to start just keeping track of single dots. So if you had no single dots, circle with the X through it. If you had 1 single dot, you just use that upside down A. If you had 2 single dots, you'd use that backward 7 looking thing. If you had 3 single dots, a triangle. If you had 4 single dots, you'd have a square. But as soon as you got to 5 single dots, you run out of symbols. There's not a symbol for 5. So we take that bundle of 5 and we move it to a new place that has a new value, bundles of 5. And now as I move it over there, I'm going to not keep track of individual dots. I'm going to keep track of bundles of 5. So I just moved 1 bundle of 5 over to that next place value. And then I continue. I had 1 bundle of 5. So now I'm up to 6, 7, 8, 9, 10. Oh, another bundle of 5. So I'm going to take that bundle of 5 and move it to a new place that has a new value of 5s. I have a second bundle of 5. So I've literally moved that bundle of 5 over to the 5's place. So that's 10, and then I need 1 more to get to 11. So I would put my 1 dot here and say, there's my 11. So now what do I have? I have 2 in the 5's place, and I have a single 1 in the 1's place. And so the number 11 in this sonic number system would be 2, 1. Now, we know, though, it's not literally 2. It's 2 bundles of 5. Through this process, I bundled 5 dots once. I bundled 5 dots twice. 5 and 5 is 10. I had 10 of my dots. So I have 2 bundles of 5, and then I have that one single dot to get to my 11. So the number 11 in sonic numbers would be the 2 followed by the 1 symbol. That's what place value is all about. Now, I hope you're getting it. Let's try. I think I have 2 more. Will you please try this one? Pause your video and try the number 20. What would the number 20 look like in the sonic number system where all we have are these 5 symbols, which means every time we get to 5 dots, we're going to bundle them and move them to a new place that has a new value. All right, pause, give it a shot. All right, the number 20. Let's start going. We first start keeping track of single dots, and we're keeping track of how many we have. And every time we get to 5, we've got to bundle them. So clearly we're going to have a 5. So 5 dots get bundled and moved over to the next place value, and we just start keeping track of how many single groups of 5 do we have, or how many groups of 5 do we have. So that 1 dot is this 5 kind of all put together, and it's a 1 bundle of 5. So let me erase because I've moved those dots over, and let's keep going. 6, 7, 8, 9, and 10. So there's another group of 5 that I'm going to bundle and move over to a new place with a new value. So there's a second bundle of 5. And now I'm at 2 bundles of 5. 5 and 5 is 10. I got to keep going. 6, 7, 8, no. 10, 11, 12, 13, 14, 15. So there's a bundle of 5 that gets moved over. And I hope you can see what's going on. I hope you've already done it. But we're now at 15, 16, 17, 18, 19, and 20. And we take that bundle of 5 and we move it over to the new place with the new value. And bam, we've got it. We've got all 20 dots accounted for. And what do we have in terms of our number? We have 4, but not literally 4. These are 4 bundles of 5 followed by no singles. And so in the sonic number system, a 20, the number 20 would be 4 followed by a 0, because 4 bundles of 5, 5, 10, 15, 20. 4 bundles of 5 is indeed 20. All right, last one, I think. Nope, 2 more after this. All right, 2 more after this. See if you're getting it. 39. What does the number 39 look like in sonic numbers? Go. All right, 39. Now, you might be getting good at this now. You might be thinking, as I keep track of ones, I've got a bundle of 5. I would have a second bundle of 5. I'd have a third bundle of 5. I'd have a fourth bundle of 5. I'd even have a fifth bundle of 5. I'd have a sixth bundle of 5. I think I would have 7 bundles of 5. Did you track all that? I'm not going to do them all, but I would have 7 bundles of 5. 5, 10, 15, 20, 25, 30, 35. I would have gotten to 35, 7 bundles of 5. And every time I got a bundle of 5, I would have moved them over to here. I would have had 7 bundles of 5. All right, now so I'm keeping track of my single dots, and every time I get a bundle of 5, I move it over to bundles of 5, the 5s place. But now look, I have 7 of them. You can't have 7. There's no symbol for 7. Remember, I only have symbols for 0, 1, 2, 3, and 4. So I'm going to have to do some more bundling. So when I get to 1, 2, 3, 4, 5, when I get to 5 bundles of 5, now these are 5 bundles of 5. Remember, every one of these dots occurred when I had 5 over here, and I bundled them and moved them over. So this is 5, 10, 15, 20, 25. So there's 5 in each of these. And so as I take 5 5s, 5, 10, 15, 20, 25, I'm going to start keeping track of bundles of 25. So I'm going to take this bundle of 25 and move it over. And when I do that, I can erase it because I've literally moved them over. I've put them all together and moved them over to that next place. So now I've got a bundle of 25. I've got 2 5s, so imagine this, 25, 30, 35, and then 36, 36, 37, 38, 39. And 4 is fine. And so 39 in the sonic number system, I would have 1 bundle of 25, I would have 2 bundles of 5, and I would have 4 singles. So in sonic numbers, the number 39 is the upside down A, a 1, followed by a 2, followed by a 4. 1, 2, 4, but not literally 1. It's 1 bundle of 25. 2 bundles of 5 and 4 1s. So 25, 30, 35, 36, 37, 38, 39. All right, now this is the last one. 257. And I intentionally done 257 to be like, you're gonna have to kind of get efficient in this because I don't think you're literally gonna draw 257 dots. So I'm hoping at this stage that you're thinking about place value ones and then bundles of 5. And remember, bundles of 5, why? Because there's no symbol for 5. So once we get to 5 and we run out of symbols, we're gonna bundle and move over to the next place value. So that 5 becomes 1 bundle. And then when we get to 5, excuse me, when we get to 5 5s, 5, 10, 15, 20, 25. When we get to 5 5s, we're going to bundle and start moving over and keeping track of how many bundles of 25. And then if you got to 5 25s, 25, 50, 75, 100, 125, you're going to bundle and move over and keep track of how many sets of 125. That's what place value is all about. Once we run out of symbols, you've got to bundle and move to a new place that has a new value. And once you run out of symbols, bundle and move to a new place with a new value, bundle and move to a new place with a new value, and you can just keep doing this forever and ever and ever. All right, pause the video and see if you can get 257 done. Go. All right, 257. Now to do that efficiently, maybe you want to start over here and think, let's see, I know with 257, you know you're going to have some bundles of 125. Let's see, how many are you going to have? If you had 1 bundle of 125 and another bundle of 125, if each of those dots was 125, 125 and 125, that would be 250. So I'm just going to keep track. I've got 250 so far. I only need 7 more to get to 257. I only need 7 more, so I won't need any 25s because that would put me over the top. 250 plus another 25 would be 275. I only have 257. But 250, I could take a bundle of 5. That would be 125, 125, 250 plus a bundle of 5, 255, 256, 257. So that would be kind of the efficient way to think through this. I hope you tracked it all. And so then in terms of symbols, I've got 2 in this place with a value of 125. I've got nothing here. I've got 1 here, and I've got 2 here. And so the number 257 in this mythical sonic number system would be the number 2012. But to what? This is the important thing. To what? 2 bundles of 125. No bundles of 25. 1 bundle of 5, 2 single ones. So 125 and 125 is 250, 255, 256, 257. All right, pause there. Think through this. If you want to go back and try this, make sure you're getting it, but place value. And imagine a kid doing this idea for the first time. They're going to feel the weight of all this too. I have a 5-year-old at the making of this video, and I know how hard it is to think about those symbols, to write them the right way, to think about what they mean, and all we do, look, all we do is move those symbols to a different spot, and they have a different meaning. How many groups of, in your case, how many groups of 5 or 25 or 125 do we have? So I'm going to stop here. we're gonna move on. Hope that was useful. See you soon.